In this lesson, we're going to learn about combustion reactions, and we'll look at both complete and incomplete combustion. So combustion is just a reaction where some substance reacts with oxygen, and it will produce one or more oxides and also heat and light. So the most common type of combustion reaction that we often look at in class and that occurs in daily life is the combustion of hydrocarbons. So that's just compounds that contain hydrogen and carbon atoms. And when those react with oxygen, they produce carbon dioxide and water vapor and potentially some other products as well when we look at incomplete combustion. So we mostly focus on these, but for example, if magnesium was to react with oxygen, that would produce magnesium oxide, and so that is also a combustion reaction. So complete combustion, this is when we have more than enough oxygen for the reaction with the hydrocarbon we have, so some amount of carbon atoms and some amount of hydrogen atoms. So there's lots of different possible compounds that can be created here with different hydrocarbons. So the words that we use for having more than enough oxygen is sufficient or excess oxygen. And so when there's more than enough oxygen for this reaction to occur, our products are only going to be carbon dioxide and water. And when this happens, the hydrocarbon, as it is burning or combusting, there's going to be a blue flame, which is a lot hotter than an orange or yellow flame, and it's a lot more efficient of a process. Because of that, for generating heat, we don't have wasted energy in other forms. So incomplete combustion is when there isn't enough oxygen, and so that means that we don't have enough oxygen to make carbon dioxide. So some of our carbon with oxygen may be carbon monoxide because there's not sufficient oxygen, or we may even have elemental carbon or just carbon on its own. And we also call that soot. So that we would say is not as clean of a process and not as efficient of a process. Because of that. So this time, the combustion of the hydrocarbon is going to yield a yellow or orange flame. And so there's going to be more energy as light, but less as heat. So it's less efficient, and then we also create carbon and or carbon monoxide, which is a problem. So just to compare the two different types. So the flame is large and blue for complete combustion when we have sufficient or enough oxygen. In incomplete, where we don't have enough oxygen, the flame is going to be smaller and then it's going to be yellow or orange. So more energy is going to the flame color, so the yellow-orange, and less is going to heat. The reaction is much faster for complete combustion than for incomplete combustion, which is quite slow. There's no soot produced for complete combustion, and there is lots of soot for incomplete combustion. So the less oxygen there is, the more soot that will be created there. And lime water tests, so remember that is one of the tests for carbon dioxide being present, and that should be present in both of them. So that would turn lime water cloudy. But depending on how much oxygen we have, we could have very little carbon dioxide produced and a lot of carbon monoxide and carbon or soot, which would then yield a negative test for lime water. So balancing a combustion reaction, the first thing that you do is balance the carbon atoms, then the hydrogen atoms, and then last the oxygen atoms. And typically when we do a balancing of our molecules in a reaction, we want to have the lowest ratio of whole numbers. So if there's an odd number of oxygen atoms in the end, you have two options here. What we very typically will do for combustion of hydrocarbons especially is we will use a fraction for the coefficient for oxygen. So if we need 25 oxygen atoms total, that's 12.5 O2s, or we would just write it as 25 over 2. So this is the one place it's acceptable to have a fraction when you're balancing equations. If you don't like that, what you can do then is double every coefficient you have and then balance your oxygen there. So always start with balancing carbon atoms, then balance hydrogen, and then oxygen last. If oxygen is odd in terms of how many atoms they are, because they come in groups of 2, either use a fraction or double the other coefficients you already had, and then balance oxygen from there. So some examples. So write the balanced equation for the complete combustion of decane, which is C10H22. So word equation is just decane plus oxygen. And because it's complete combustion, there are only 2 products, carbon dioxide and water. So converting that to a skeleton equation, we were told that decane is C10H22, and that's a liquid. Oxygen we know is a gas. Carbon dioxide we know is a gas. And because the temperature is so high in combustion, water is actually going to be a gas because we're going to be over 100 degrees Celsius. We're not talking room temperature, so it's not a liquid. So balancing our equation here, so I have 10 carbon atoms, 22 hydrogen atoms, and 2 oxygen atoms. And on the other side, I have 1 carbon, 2 hydrogen, and then I have 2 oxygen from carbon dioxide and 1 from water, so 3 oxygen there. So the rule was to first balance carbon. So I have C10H22 on this side, and I'm just gonna, switch to a different color here. So to balance my 10 carbon atoms, I'm going to put 10 in front of carbon dioxide. And then hydrogen is next. So I have 22 hydrogen in the reactants, and they come in groups of 2 on the other side. So 11 groups of 2 will give me my 22. So I now have 22 hydrogen and I have 10 carbon. And this has also given me 10 times 2 oxygen, so 20 there, and 11 times 1. So 20 plus 11, which means I now have 31 oxygen. So this is where if you end up with an odd number at this point, you can either double everything, so this becomes 2, 20, and 22, and then you can appropriately change how many of everything you have and put a whole number there, or 31 halves. So it's always the number of oxygens you need, and then half the amount because oxygen comes in groups of 2. So this is the one place that it's acceptable to use a fraction as you are balancing your equation, is for the number of oxygens in a combustion reaction. So if you didn't like that, then you would have 2 of this, 31 oxygens, 20 carbon dioxides, and 22 waters if you didn't like to see fractions there. So in incomplete combustion here, you do not have to be able to determine the products, because balancing here is going to depend on how much carbon dioxide, how much carbon monoxide there is. And that's something that you can't figure out. So unless you're given parts of this equation, you can't actually determine the products and balance it, because we could have different amounts of carbons here. So if I had more carbon here, I would need less oxygen because this product isn't using any oxygen. So this you need to be able to identify it's an incomplete reaction. And if I give you a partially balanced, so you can see here that this is partially balanced. So I have 10 carbons here. So I have 2 so far and 6, so that's 8. So I would need 2 more to balance my carbons. And I have still 22 hydrogen, so that's going to be the same here. And then to balance my oxygens on this side, so I have 2, 12, and 11. So 2 and 12 is 14, 14 and 11, so I have 25 oxygens there. So I had 2 and 12 and 11 oxygens total. So 25, so once again, this is where 25 over 2. 25 divided by 2 is 12.5, and then times 2 gives me the 25 oxygen atoms in my reactants. And if you didn't like that, then 2, 25, 4, 4, 12, and 22 to balance there.